Lesson 7-1, Lines. Chapter 7 is all about conic sections, which are the intersection of a plane with a double cone, and it can give us several shapes. We can get a circle, an ellipse, a parabola, and a hyperbola. So what it looks like is like this. We have a parabola when the plane is parallel to the side of the cone. You get an ellipse when the plane cuts all the way through a cone, and a circle is a special type of ellipse. Get a hyperbola when the plane intersects both cones, like when it's parallel to the axis of the cones. You get two parts there, one in each cone. And then we get the degenerate conic sections, a point, just where the plane intersects the point of the cone. Or a single line when the plane is tangent to the side of a cone. Or intersecting lines when the plane goes through the center of the cones along the axis of the cones. Today we're looking at the lines. So for lines can be written in standard form, ax plus by plus c equals 0, or slope-intercept form, y equals mx plus b. The slope and slope-intercept form tells you the rise over the run, how steep the line is. We're also going to talk about how steep the line is with inclination. And so inclination describes the steepness of the line, and it is the angle it makes with the positive x-axis. So if you look at this picture, this graph, if I drew a right triangle there, you see we could find that angle using inverse tangent. So tangent would be y over x. Oh, but wait, that is the rise and the run, so that's the slope. So the tangent of the inclination equals the slope. And that would be between 0 and 180 degrees. So if you get, you do your inverse tangent of the slope to get the angle, and you get a negative angle, just add 180 degrees to bring it around to quadrant 2, and that will work. So let's find the inclination of this line. To do that, we need to find the slope. So let's solve it for y. So I'll subtract the 4x and the 5. Then I'll divide by the negative 2, so we'll get y equals 2x plus 5 halves. All I care about is the slope. So tangent of the angle equals the slope. And so I'll do inverse tangent and get about 63.4 degrees. So the inclination is about 63.4 degrees. We could also find the angle between two lines, and so we're looking for this angle up there. Looking at all this geometry and the angles I have here, these two angles are a linear pair. Now theta 2 is an inclination of line 2. Therefore beta is 180 minus theta 2. I have a triangle in the middle, theta 1, which is the inclination of the first line, plus alpha plus beta is 180. So I could solve for alpha being 180 minus theta 1 minus beta. Oh wait, but beta is 180 minus theta 2. The 180s will cancel, and we have minus a minus, so that becomes plus. So alpha is theta 2 minus theta 1. So that's just the difference of the inclinations. Well, the angle we're looking for is equal to alpha because they're vertical angles and are congruent. Therefore, the angle between two lines equals the difference of the inclinations. But we might want our angle between the two lines in reference to the slopes of our two lines. Well, we could take a tangent of both sides and use a difference formula for tangent. Look back in your book in the trigonometry section if you want to find that difference formula. And just remember that tangent of the inclination is the slope. So this is really slope 2 minus slope 1. And we'll put the absolute values so that we get an angle between 0 and 90 degrees. So what is the angle between these two lines? Again, I need to find the slopes. So this first one, if I subtract the 2x, that slope is negative 2. Here if I subtract x and then divide by the negative 1, I'll get 1x minus 2, so that slope is 1. Alright, so tangent of the angle between the lines, slope 2 minus slope 1 over 1 plus slope 1 times slope 2. Alright, so that would be 1 minus a negative 2 over 1 plus 1 times a negative 2. Alright, so that gives us 3 over negative 1. If I use the absolute values, that would be 3. So the inverse tangent of 3 is about 71.6 degrees. So the angle between those two lines is about 71.6 degrees. We can also find the distance from a point to a line. Now in geometry, we would have had to find the equation of the black line and find its slope. And then do the reciprocal, negative reciprocal of that slope, and then draw a line from the point to the black line, draw a segment there that's perpendicular. And then you had to find the point of intersection, and if it wasn't nice like that, then you need the equation of both lines and solve the system of equations to find the point. And then once you knew that point, you could use the distance formula. Or we could look up in your textbook or anywhere online, they'll derive this formula. The point from a line, or distance between a point and a line, in that format, standard form, is that. So what is the distance from our point to the line? Well, this is x1, y1. This is A, B, and we're missing C. So C is 0. It should be in there. But our formula was D equals absolute value of AX1 plus BY1 plus C. So that's our line where we've plugged in our point. Over the square root of a squared plus b squared. So our distance appears to be 4 times 0 plus 3 times 2 plus 0. Square root of 4 squared plus 3 squared. So the top is 6 The bottom is 5. So it appears to be 6/5, or 1.2.